I'm sending a data, and that data has to be received by a receiver, and he should be in a position to understand what I have sent. So there we need the protocols. So all these things are combined together will form a data communication. So here the term data communication is nothing but the exchange of data between two devices or two persons. For example, the best example is now I am communicating with you. Okay, I am delivering a content to you, and you are able to understand that content. You are the receiver, and I am the sender. And what I am talking is the data actually being transmitted, and it is being transmitted through a medium. It may be a wired medium or wireless medium. It depends on the device what we are using, or it's a combination. It may be a combination of wired device and wireless device. And the fifth one is the protocol which we need to follow. So in general, the data communication system has 5 components. The first one is the message, that is the data. And the second one is the sender. The third one is the receiver. The fourth one is the transmission medium. And the fifth one is the protocol. Okay. So as I said earlier, we should have a sender and a receiver. And we should have a data or a message which we need to transmit. And the medium may be a wired device or it may be a wireless device. And we should have certain protocols. Okay. First, the message what I want to convey you will be transferred from me to you. Okay, so I am the sender and you are the receiver, and I am giving you a lecture in data communication. So that is the actual message what I am transmitting, and I am transmitting this message through a medium, and this medium may be a wired medium or maybe a wireless medium. Okay, protocol. What is actually protocol? Protocol means the set of rules. What is that rule actually? What do you mean by that? Actually, protocol is a standard or a common thing which we need to follow between the sender and the receiver. Okay, so here I am talking in English with you, and you are in a position to understand what I'm talking since you have the knowledge about English. Suppose if I use a different language, for example, I may use French or German. Can you able to understand? Is it possible for you to understand that? Can I get any reply? For example, if I talk some other language, can you able to understand?
No, sir.
Why? Because you don't have the knowledge of that such language, right? So here we need a common language in order to do communication. So likewise, in data communication also, we need to follow a set of standards and protocols. And this protocol will define you what the sender is sending, and the receiver can able to understand the message which is sent by the sender. Okay, so that is what we call it as protocol. And here this data, it may be a text message, or it may be a number, or it may be an image, or it may be an audio voice, or audio signal, or it may be a video signal. Okay, any data can be sent through the channel. Okay, so the data, it may be a text data, or it may be a number data, or it may be image, audio, or video signal. Anything we want to send, we can send. The only thing is we should have all these 5 sets, that is message, sender, receiver, transmission medium, and protocol. These are the basic things which we need to have a data communication. Okay, and the next one is data flow. How the data is going to flow. For example, now I am sending a message. Okay, and you can also send me a message. That is, here in this channel, you can talk and I can talk. My voice is also audible to you, and your voice will also be audible to me. But in few cases, only one person can send the data. And likewise, only one person can send the data at a time, but both can able to send the data and both can able to receive the data, but at a time only one person can able to send the data. So likewise, we have different data flow concepts. The first data flow is simplex. The second one is half duplex, and the third one is full duplex. Okay, simplex is nothing but the data which will be sent to the receiver. That's it. That's what we call it as simplex. So in simplex, only one-way communication. Only one person will give you instruction, and the other person has to obey by that. He cannot able to reply back to the other one. That is what we call it as simplex. It is a one-way communication. And the next one is half-way communication. Half duplex. In half duplex, both can communicate, but not at the same time. Okay. The first person can able to send the data to the second person, and once the data is received or the sender has finished sending the data, the receiver can send the data. That is what we call it as half duplex. Okay. And the third one is full duplex. Full duplex means both can send the data and both can receive the data. So that is what we call it as full duplex. Okay. The first one, simplex, the best example is a one-way road. Okay. When you're traveling in road, okay, if it has been mentioned as one way, only in one direction, everyone can travel. In the opposite direction, no one can able to travel. That is what we call it as simplex. The best example is from a server, a data has been sent to the client machine. Or the best example is the keyboard. Okay, the keyboard can send the data to the system, but the system cannot instruct the keyboard. That is simplex transmission. And likewise, the output device is nothing but the monitor is output device which can able to get the data, and it cannot able to send the data. That is what we call it as simplex. And half duplex, the best example is, can you give me an example for half duplex? Do you have any idea about that?
Walkie-talkie.
Yes, exactly. Walkie-talkie is a best example. Only one person can able to send the data. The other person can listen to that. Once that data is transmission is over, then the other person can able to send the data. And full duplex, as I told you earlier, right now we are in full duplex mode. So both can able to send the data as well as receive the data. That is what we call it as data flow. And now comes the network. So how the network is being formed in the sense? Network is not a simple thing. It's a combination of lot of systems. Not only systems, lot of devices. Okay, it's a combination of computer, printer, scanner, even mobile devices. Everything can be connected in the network. So that is what we call it as a network. Okay, a set of devices which are connected together will form a network, and that is a simple network. Okay, so a network is a set of device connected by communication links. Okay, a node can be a computer, printer, or any other device which has the capability of sending and receiving the data generated by other nodes on the network. And the link, it can be a cable, ordinary coaxial cable or optical cable, or it may be a twisted pair, whatever we want, we can use. If it is a wireless, then the medium will be air. Okay. So if you want to connect any system, if you want to form a network, then we should follow certain things. The first one, the performance. We have a criteria. There we have the performance. Okay. Because if you connect everything, if the performance of the systems are poor, then what happens? The network will get struck. No one can send the data and no one can receive the data. Or if the system is very slow, then there also will become a problem. Okay, so the first one is performance. Okay, and it depends on the network, and it is measured in terms of delay and throughput. So as I told you earlier, a system must have the capability of sending the data or receiving the data very quickly. It has to do the process very fast. So then only we can form a network. Next one, reliability. Reliability means, see, for example, we have some 10 systems which are available in the network. We cannot give assurance that all the 10 systems may work properly, and sometimes some system may get failure due to the system problem or due to the link problem. So we should be in a position to identify which system is working and which systems are under failure mode. So once if it goes to failure mode, we have to try to reconnect it as soon as possible in order to maintain the network. So that is what we call it as reliability. So failure rate of the network components is very, very important, and is measured in terms of availability and robustness. Okay. Third one is security. And now I am sending you a data. Okay. Now we are all talking here. We have a conversation, and I'm giving some data. Okay. And what happens in the sense, in the meanwhile, somebody is hacking this device and they are giving some data. Okay. I'm sending the data to you, but you are not receiving that data. Instead of that, you are receiving some other data. What happens? So there comes the problem. So security is also very, very important. The data which we are sending must be secure and safe. And at the same time, because of the traveling time or because of the traveling medium, the data may be affected by noise. If it is affected by noise, how come we can able to regain the data? If the data is lost, what to do with that? So all those things will be there in the security. Okay. So the data protection against corruption and loss of data. And this may be due to the error or malicious users. So these three things are the very important things which we need to take care when we talk about the network. So performance, reliability, and security are very, very important when we form a network. Next one, physical structure. How the structure will be, how we can able to connect a system, how we can able to form a network. Okay. So initially we had only one system which we used to connect it to internet. But if it is a big office or if it is a college, then we have to go with many systems. So all the systems should have connection to the internet. That is very, very important. So likewise, we have two sets of connections, two type of connections. One is called the point-to-point connection, and the other one is multi-point connection. Point-to-point means single transmitter and receiver will be there. That is, only two persons will be connected. They can able to send the data and receive the data. Either one of them will send the data and the other one will receive. That is what we call it as point-to-point connection. And the next one is multi-point connection. Okay, here multiple systems will be there, and everyone has to communicate with each other. So that is what we call it as multi-point connection. Okay, and then comes the physical topology. Topology means some set of structures or the method in which we are connecting the systems. That is called as physical topology. That is connection of devices and type of transmission. It may be unicast, multicast, or broadcast. Okay. Till now, you have any doubt? Or I'm going very fast? If it is so, let me know. I'll slow it down. Any feedback regarding this?
No, sir.
Okay, fine. Okay. So now, as I told you earlier, point to point and multi-point connections. Point to point means you will have two stations, station 1 and station 2 will be there. Assume that this is station 1 and this is station 2. Okay, and you have a link between these two stations so that station 1 can send the data to station 2 as well as station 2 can also send the data to station 1. This is called point to point connection. And likewise, multi-point in the sense we'll have one server and that server can able to send data to all the stations, or station can able to reply back to the server. Whatever we want to do, we can do. This is called as multi-point. Categories of topology. So topology means in which way we are going to connect the systems in a network. That is what we call it as topology. So here we have actually 4 different types of topologies. The first one is mesh topology. The second one is star topology. The third one is bus topology. The fourth one is ring topology. Okay. Now we'll see what is mesh, star, bus, and ring. Okay. So here we have the mesh topology. And this is a, here in this, all the 5 systems are connected to each and every system. Okay, it's a fully connected mesh topology. Assume that we have station 1. We have station 1, station 2, station 3, station 4, and station 5. Okay. So if I want to connect all these 5 stations, okay, then I need this many connections because station 1 and 2 must be connected. Station 1 and 3 must be connected. Station 1 and 4 must be connected. Station 1 and 5 must be connected. Okay. So in order to connect all those things, what I have to do is I have to take 4 connections from one system, because from 1 to 2, 1 to 3, 1 to 4, 1 to 5. So I need 1, 2, so 2, 3, 4. Okay. In order to connect one station with the rest of the other stations, I need 4 connections. Okay. Similarly, for each and everything. So totally, I have around 10 links here in this diagram. 1, 2, 5 systems to be connected, then I need 10 links. Okay. Similarly, if I want to connect 100 systems, then I need 100 links. So the connectivity problem will be increasing. The complexity is increasing here in the case of mesh network. But here, fault identification is very easy. At the same time, error for failure can also be easily identified. For example, a link between 2 and 3 has been failed. Only system 2 and 3 cannot able to connect. Okay, rest of the other systems in the network can able to communicate with each other. Even system number 2 can able to communicate with system number 4, and 2 can able to communicate with 5 and 2 can able to communicate with 1. But 2 and 3 cannot able to communicate because of the system failure happened between 2 and 3. So that is why the robustness is very high in the case of mesh network. The only drawback what we face here in the case is the number of network links. How we can able to identify this network links in the sense we have a formula to calculate that. The formula is n into n minus 1 divided by 2. Okay. So by using this formula, we can calculate the number of links required to connect the systems. Okay. Here we have 5 stations, for example. So n is equal to 5. So n in 5 into 5 minus 1 is 4. So 5 into 4 is 20. 20 by 2 is 10. So totally we need 10 links to connect all this entire system. Secondly, the start topology. Okay, so here we have the star topology. The star topology is a little bit simple when you compare it with the mesh topology. Here the complexity is very, very less because only one link is necessary for one system. Okay, here we have station 1, 2, 3, 4 stations are there, and all the 4 stations are linked with the hub. Okay, and it needs only one link. So here we have station 1, 2, 3, 4, and if suppose a link failure happens between station 1 and the hub, only station 1 is not connected there in the network, but remaining all the stations are connected there in the network. Okay, so if failure occurs between station 1 and the hub, then only station 1 will be ideal and remaining all the 3 stations will be there in the still in the network. Okay, but here also we have a drawback. The drawback is if the hub gets failed, what happens? The entire network will be collapsed. All the systems will become an individual system. So that is the major drawback which we face here. But rest of the other things are advantages. You can easily identify the fault. You can easily identify the failure. You can easily, the complexity of the network is also reduced here when you compare it with the previous case. There we need 10 links for 5 systems, but here we need 5 links for 5 systems. Okay. The next one is bus topology. So it is just like a bus. Wherever you want to get in, you can get in, and wherever you want to get down, you can get down. Likewise, you can a bus will be running continuously. You will have a bus-like structure which will be running continuously so that anyone can tap this line and you can connect the system. And this point is called as the drop point, and the point where it is connected is called as the tapping. Okay, by using this we can able to connect it. So it goes on continuously from one end to another end. So all the systems will be connected there in the bus. But here the complexity is very less. Only one cable is needed so that all the systems can able to connect it in the network. Okay, I can connect any number of systems there in the bus topology. Okay, so can you tell me what is the drawback here? What's the drawback? Can anyone tell me the drawback of this?
Failure of bus.
If the bus gets failed, the entire network will be collapsed. So that is the major drawback which we face here in the case of bus topology. Okay, suppose a failure happens somewhere here. Okay, this entire thing will be in a different network, and this portion will be in a different network. Anyone from this side, we cannot able to communicate to this side. Okay, that is the major drawback which we face here. But the complexity is not there. It is very simple. Number of links is very, very less. But identification of failure has become a bigger drawback. At the same time, failure happens when the entire network will be split. You have a different, so that the person from one end cannot communicate with the end. The next one is the ring frequency. So here a ring-like structure will be running around the room, so that anyone can connect it to the ring, okay, with the help of the ring. Okay. So this is also something related with bus topology, but only the thing is here it will be ring-like structure. Okay. So here also anyone can able to connect to this. Okay. The same drawback what we face there in the case of bus topology is applicable here. Okay. Any failure occurs at any place. For example, here the failure is okay. So the entire network is completely unused. So that is why there is a drawback here in the case of another. But this drawback can be overcome by using one more ring. That is, the secondary ring will be there like this, so that if failure occurs in the first ring, then everyone can able to connect to the secondary ring. Both are connected at the time, so that we can easily My voice is not clear.
Yes, sir.
Okay. Previously it was okay. Huh? Now it is become. Is it okay now? My voice is clear.
Little bit, sir.
Little bit. Huh? Okay. Wait, let me check it. Okay. Is it okay now?
Okay, sir.
So this is also subject to the bus topology, but the only thing is it will be ring-like structure. So in order to overcome the drawback which we faced in the bus topology, the same drawback is available here also. If we want to overcome that, we have one more extra ring-like structure, and in that link, all the systems will be connected. Once a ring failure occurs, then we can able to connect the second ring, so that we can easily come up with the problem and then solve. That is the advantage of this. The next one is hybrid. Okay. So here in this hybrid, we have two topologies combined together to form a single topology. That is called as hybrid. So here all the systems are connected plus two points. My voice is not audible. Can you hear me? Is it okay now? Is it okay now? Is it okay now?
No, sir, voice is disturbing.
Voice disturbing. 1 minute. Is it okay now? Check it. Is it okay?
Yes, sir.
Okay, fine. Okay. So here we have a combination of bus topology and star topology. So here all the systems are connected using bus topology, and here also everything is connected using bus topology, and here also it has been connected using bus topology. But all these three buses are connected using a hub. Okay, so here we use the combination of bus topology as well as star topology. So this may be available in a separate room, and this may be in a separate room, and this may be in a separate room. All these three different rooms are being connected with the help of the hub, so that we can have a hybrid topology. The next one is the categories of networks. So actually speaking, we have three types of networks available. One is the local area network. The second one is wide area network. The third one is metropolitan area network. We are very familiar with LAN and to the maximum. We know wide area network also. LAN can able to connect only to a shortest distance to the maximum of 2 miles. Okay, and it can able to provide you only a local connectivity. But wide area network, WANs can able to connect to a longer distance. It is actually worldwide connection. Okay, so we can have the entire world to be connected by using this WAN, wide area network. And the third one is the metropolitan area networks, which can able to provide a connectivity over a area as a city, entire city, or an entire building, or an entire campus to be connected. So that is what we have three different categories of networks: LAN, WAN, and MAN. LAN can be expanded as local area network, WAN can be expanded as wide area network, and MAN can be expanded as metropolitan area network. So this is an example for LAN. So here in a lab, we have 12 systems. All the 12 systems are connected with the hub. So this is what type of config topology is used here.
Hybrid.
It's not hybrid. It's only one topology. It is star topology. Okay, because we have 12 systems. All the 12 systems are connected with the hub. We have different connections for all the systems. Each and every system is connected individually to the hub. This is star topology. Okay, and this is an example, best example for LAN connection. Next one, WAN switched. A switched WAN. Switched WAN means, as I told you earlier, WAN is meant for the entire, to connect it to the entire world. So that's what we call it as switched WAN. Okay. Shruti, Shruti, just mute your mic. Okay. We have less than a minute. Okay. If possible, we'll continue this tomorrow. Okay. Can I have your feedback regarding this topic, what I told you today? Is it okay or I need to do some modifications?
Okay, sir.
Okay, sir.
Okay, fine. Okay.
Okay, sir.
Tomorrow also I'll give you the timings before that. Most probably we'll have it by the same time on today what we had. Okay. So tomorrow also we'll have
Okay,
it by 12 o'clock and make yourself free. Okay. And if you have any
okay,
doubts,
sir.
you come out with your doubts. Okay. Tomorrow we'll continue the class. Okay. Thank you.
Thank you, sir.